This video is going to cover our 6.3a lesson, Special Angle Relationships. And we're going to start off with two vocabulary words. The first one is vertical angles. Vertical angles. Two lines that intersect form vertical angles. Vertical angles are pairs of angles that are always opposite one another rather than adjacent, which means next to each other, and do not share a common ray. So, a way to think about this would be like your neighbor across the street. You don't share a fence with them, but you can kind of see them and you have that street in common. So, if we give ourselves an example, if I draw two intersecting lines, and I put some labels on here. So I'm going to put some points. I have point A, B, C, D, and E. And if I want to talk about some vertical angles, angle ABC and angle EBD are vertical angles because they're across the street from each other. It's kind of like they're touching noses but not holding hands. Then we have angle ABE, and that's going to be vertical to angle CBD. Those are right across from each other as well. So let's go ahead and write those out. We have angle ABC is vertical with angle EBD, and we have angle ABE is vertical to angle CBD. Now, our next vocabulary word is adjacent angles. Two angles are adjacent if they have a common ray, so they share a side and a vertex. So they're right next to each other. So if I'm looking at that same diagram that I just drew in my previous example, I'm going to recopy it here so we can write on it. So A, B, C, D, and E. An example of adjacent angles would be angle ABC, and it's going to be adjacent here with angle ABE. Those two are adjacent. So if we look at it, we can also say these two are adjacent, and these two are adjacent. These two, they share a common ray and then a common vertex. So let's give ourselves an example. Angle ABC and angle ABE. Notice that the middle letter is the same because they share that common vertex. So if we look at this diagram up here, we can look at number 1 where it says name at least two vertical angle pairs, and then it's going to ask us to use different colors. We don't have to, that's okay. So I'm looking for two angles that are sort of across the street from each other. So an example might be this angle and this angle. These two angles are across the street from each other. Or maybe this angle and this angle. They share the vertex but are across the street from each other. So I'd like you to find two other sets of angles and fill it into number 1. You're also going to be doing number 2, which is to name at least two adjacent pairs. So remember, adjacent are ones right next to each other, like this angle and this angle. These two angles are adjacent to each other. So again, I'm going to give us an example of each one of these, and then you're going to try one on your own. So this could be like angle EGD. Find that up on your picture. And angle FGH. An example of adjacent angles would be something like angle GFE and angle AFE. All right, I want you to try one more pair for number 1 and number 2 for vertical and then adjacent angles. Hit pause now and give it a try. All right, so I provided a couple more examples of vertical angles and adjacent angles. Did you choose one of those or do you have a different one? There's lots of ones to choose from. Let's take a look at number 3. What seems to be the relationship between measures of two vertical angles? So if I go back to my picture, what do we notice about those two angles or these two angles? What we notice is that they look about the same. Do you agree? This angle is the same size as this one. This angle is the same size as that one. And that's absolutely true. So what we're thinking about here is that vertical angles are congruent. Now, we can test this by giving ourselves another example. And if you use a straight edge, it's a little easier to tell. But we can notice that this angle right here and this angle right here, yeah, they look like they match. They look like they're the same degrees. So yes, this example definitely supports my conjecture. All right, we're going to do another vocabulary word on the next page. So let's go ahead and flip, called supplementary angles. And these are two angles whose sum is 180 degrees. So two angles whose sum is 180 degrees. Now I know 180 degrees is a straight angle. So I'm taking that straight angle and breaking it up into two pieces. So if I put some labels here, point A, point B, point C, point D, I can say that angle ABC, and I'm going to put the measure of angle, that's what that M stands for, that means I'm talking about the degrees, plus the measure of angle DBC equals 180 degrees. I can add those two up and put it equal to 180. Now, supplementary angles don't have to be adjacent. They don't have to be touching each other. They could be two totally separate angles. I could have one angle over here and maybe one way over here, and it could be flipped upside down or backwards. It doesn't matter. As long as the two add up to 180, they're supplementary. So I'm going to add a little note here that says doesn't, or actually don't would be a better way to say that, don't have to be adjacent. They don't have to be right next to each other. That's okay. All right, so if I'm looking at number 4, find and name at least one pair of supplementary angles that are adjacent in the diagram and one pair that are not adjacent. So maybe one example of them being adjacent could be this guy and this guy. Those two form a straight line right here, and so they add up to 180. So this would be something like angle EGD and angle DGH. And then we're looking for ones that are not adjacent. So ones that aren't necessarily touching, but will still add up to 180 degrees. So this could be like something EJI. So this guy right here, and EFG, this guy right here. Those two angles will also add up to 180 degrees, but they're not adjacent. They're not right next to each other. So angle EJI and angle EFG. Okay, so let's see how this will help us when we're trying to solve problems. And it's very, very handy if we have unknown angles. So our next problem say for each pair of intersecting lines below, find the 3 missing angles formed, justify your answers in the table. These are not drawn to scale, so pulling out your protractor here is not an option. We're going to actually use what we know about vertical and supplementary angles to help us out. So as I look at this first one, I'm not going to worry about the table over here yet. I'm just going to fill in what I know and see what happens. So I know that this is 116 degrees. And across the street, that vertical angle is going to be the same, is 116 degrees. Now, I'll also notice that these two angles here, they form that straight line. Do you see it? Right there, this angle and this angle form that straight line, which means that 116 plus whatever that angle is, x, is going to be 180 degrees. Now, you might be thinking to yourself, Miss Coulter, isn't it just easier to do 180 minus 116? Yeah, it's definitely shorter, but I want us to get in the habit of thinking supplementary are two angles that add up to 180 degrees. That way, when we start having unknowns, it's a little easier for us to work with. So I'm going to add a negative 116 to both sides. And you can use your calculator here, and we'll work that out and we get 64. So we find out that this is 64 degrees because these two angles were supplementary. Then to find this angle here, I have some options. These two angles are supplementary. These two angles are supplementary. And this one over here, they're vertical. So it's actually a little easier to work with. So I'm going to say if they're vertical, that means this has to be the same thing. So I've now found my three missing angles. I need to fill in my table. So I'm going to take angle CEB. So CEB, it's that one, was 116 degrees. And we found that one because it was vertical to angle AED. And then it says angle DEB. So DEB, that was this one. We found out that's 64 degrees. And we got that because they were supplementary, that they added up to 180 degrees. So supplementary to angle AED. And then to find this one, we had a lot of different options. Remember, we could have thought of them as supplementary or vertical. So we found out that angle AEC is 64 degrees, and it's because it's either supplementary to angle AED, or we could say that it's vertical to angle DEB. So we have some options there. All right, so I want you to use what we just did in number 5, and I want you to try number 6 on your own. When you think you have all the angles and your reasons, then go ahead and come back to the video. So hit pause now. Okay, let's see how you did. So we had the 91 degrees here. That was given. If we go across the street, we can fill this one in with 91 degrees because they are vertical angles. So that's what we're seeing right here to find angle DEB. And then to find angle CEB, so this guy up here, we see that they form that straight angle. This guy and this guy form the straight angle. That means they add up to 180 degrees. So there's my equation to show my work. And I find out this one is 81 degrees because it was supplementary to angle AEC. And then to find this last one, angle AED, we have two options. We can say that it's vertical to angle AEC, or I'm sorry, supplemental to angle AEC, or vertical to angle CEB. All right, we're going to pick up on number 7 in our next video. So go ahead and hit pause and move on to the next one.